Hello everyone, welcome to this video. This video is about graphing straight lines. So we want to look at how, when given an equation of a straight line, you can represent that line on an x and y coordinate system, or how to graph it on the x and y plane. So in the previous video, we discussed how to come up with the equation of a straight line, and that is like a standard equation. There are two types of equations. There's the general equation, and then there's the standard equation. The general equation is y is equal to mx plus c, where m represents the gradient and c represents the y-intercept. And then wait, let me say that again. The standard equation is y is equal to mx plus c, where m represents the gradient and c represents the y-intercept. Then the standard equation is given by ax plus by plus c is equal to 0, where a, b, and c are constants. Then x is a variable and y is a variable. Now, when it comes to graphing lines, there are a number of methods that are available. But I'm going to talk about, I think, 2 or 3. The first one is how to graph using the y-intercept and the point. Then the other one is how to graph using the x-intercept and the y-intercept. And the other one is the one for using random points. So as I was saying earlier, let me just write the general equation and the standard equation somewhere. Standard equation is mx plus c. Then the general equation is ax plus by plus c is equal to 0. So the equation of a line can be given in either the standard form or the general form. And it's up to us to identify which form it is in and then see how to graph it. So I was saying that there are several methods of graphing, and I'm going to talk about at least 3 in this video. And the first one that I mentioned was the one for using the y-intercept and a point. So let's say we're given the equation y is equal to, say, 2x plus 3. So when you look at this equation is in the standard form. And in the standard form, we know that m, which is the coefficient of x, is the gradient, and then c is the y-intercept. So whenever it's in like its general whenever it's in its standard form, keep on mixing the two. The standard form is y is equal to mx plus c. Then the general form is the other one. So whenever it's in standard form, it's easy to tell what your gradient is and what your y-intercept is. So in this case, since it's in standard form, our gradient is simply m, which is the coefficient of 2. What am I saying? Our gradient is 2, which is the coefficient of x, because from the standard equation here, m is the coefficient of x. So our gradient m is equal to 2. And then our y-intercept c is equal to 3, positive 3 that is. So now that we have our gradient and our intercept, to graph this line, we know that the intercept, the y-intercept to be specific, is the number at which the line crosses the y-axis. So if this is my y-axis, and this is my x-axis, let me just extend my y-axis a bit so that it's longer. Something like that. So as I was saying, the y-intercept is the number at which the graph crosses the y-axis. So in this case, the graph is crossing the point which is 3 on the y. So let's say our 3 on the y is there. For us to graph this using this method, we already have the y-intercept there. So we simply need to find another point. And to find another point along that line, we give x any random value. So if I want, I can say x is equal to 1, or x is equal to 2, or x is equal to 10, whichever is easier for me. So in this case, I'll say x, let x be, when x is equal to 2, when x is equal to 2, then I'll use the equation to find the value of y. So y is equal to 2 multiplied by 2 plus 3, like that. When I do my mathematics, 2 times 2 is 4, 4 plus 3 is 7. So when x is 2, y is 7. So this gives me a point 2, 7, like that. Then I go ahead and graph this point. So 2 on the x, 7 on the y. So let's say my 2 is somewhere here. My 7 is, say, somewhere there. Like that. So I have 2 points. I have the y-intercept and the point that I've just discovered along that line. And using those 2 points, I connect them with a straight line, like that. Then I would have graphed my line. So to graph a line, basically you just need 2 points. if you can find one point on one end and another point on the other end, then you connect those 2 points to a straight line, then you'd have graphed the line. So this is how you graph a line using the intercept, the y-intercept to be specific, y-intercept and the point. So let me see if we can look at another example on this. So say we're told the gradient of a particular line, the gradient of a particular line is say 4. Okay, let me use a negative, say -4. And then the y-intercept is 5. So C is equal to 5. Then we're asked, having been given these two values, we come up with the equation of the line, standard equation of the line. And then we graph that equation on the x and y plane. So how do we come up with the equation? If we're given M and we're given C, we use a standard equation guideline, and then we just replace the values. So while there's M, you put -4, while there's C, you put +5. So in this case, -4x plus 5 is the standard equation for this line. And having found the standard equation, we proceed to graphing it on the x and y plane. So we have for y like that, and then x like that. Maybe I can mention in passing that whenever you have a negative gradient, it means the line is slanting in such a way that it's coming from a high and going to a low. So the left side of the line is like up on top, and then the right side is like down below. Then if it's positive, it's coming from like a low point going to a high point, so it's increasing. When the line is like increasing, the gradient is positive. When the line is decreasing, the gradient is negative. Like in our previous example, we had a gradient of 2, +2. So our line was increasing going to the right. It was coming from down on the left, going top to the right. But then in this case, you see that because our gradient is negative, it's going to decrease. The line is going to decrease to come from a high and go to a low. So we said, first thing is you find the intercept, which is a number on the y-axis, and our intercept here is 5. So this 5 is somewhere there. This say 5 is there. That's our first point. We have to find our second point. Again, we're going to give x any random value. So let's say, let x be, let x be 3. So when x is equal to 3, then y is equal to 4, -4 multiplied by 3 plus 5 negative 4 multiplied by 3 is negative 12. Negative 12 plus 5 should be 7, I think. Negative 7, yes. So this second point is a point that's at 3, comma negative 7. So we have our second point. I can plot that. So let's say 3 on the x-axis is somewhere there. And then, okay, let me just extend it a bit so that the line looks nice. Say 3 is somewhere there, and then negative 7 is somewhere there. Then our point, our second point, will be somewhere here. Somewhere there. And since we have the 2 points now, we can graph. My graphing is not. Okay, let me just do this. Then I edit everything. So my line is not going through exactly like the points because my numbers are imaginary. But when you join the two, you have a line like that. So let me just edit a bit. Let's see, I can remove this. Okay, let me just do this. So my 5 is there, and this point is there. So when you plot those 2 points, you connect them with a straight line, and you have your graph of that line. So we covered case 1, where we use the y-intercept and a point to find the graph of the line, or to come up with the graph of the line. Let's now see how you can come up with the graph of a line using the x-intercept and the y-intercept. So say you're given an equation in the form, let me use black. You're given an equation in the form 2x plus 3y plus 6 is equal to 0. And you're told to graph this line on the Cartesian plane. So as we can see, this equation is in the general form. It's not in the standard form. So one way you can go about this is you write this in the standard form and then use the previous method to graph it. Or you can use the method that we're going to look at, which is the method of using the x-intercept and the y-intercept to have 2 points, and then you join those 2 points. So basically, as you're trying to graph a line, the basic thing is to come up with 2 points, like on the plane, which you can connect with a straight line. So in the previous method, we're using the y-intercept, and then we're finding another point, so that we have 2 points to connect. In this method, we're using the 2 intercepts, the x-intercept as well as the y-intercept. Then we're connecting those to come up with the graph of the line. So now how do you do this? what we should know is that when we have an x-intercept, we have the x value. Let me just say x, like that's x, let's say x1, just for reference sake, comma, 0. And then when you have the y-intercept, you have 0, comma, y1. This y1 and x1 are just for like reference. What I mean is, whenever you have an intercept on the x-axis, there will be an x value, which will be a number on the x-axis, and then for y, there will always be a 0. So say my x-intercept is -2, then as a point, it will be -2, 0. If my x-intercept is 5, it will be 5, 0. The same with the y-axis. If my y-intercept is at 2, then it will be 0, 2. If my y-intercept is at -15, it will be 0, -15. So you always have a case like this. And so this is what, this is the idea you use to come up with the intercepts. So you say on the x-intercept, y is equal to 0. So to find that point, the x value on the intercept for this line, you just replace y with 0, and then you solve the equation. So let's do that. So 2x, the equation, plus 3, what is y? We put 0, like that, plus 6 is equal to 0. Then we know that whenever anything multiplies with 0, the answer is 0. So 3 multiplied by 0 is just 0. It remains 2x plus 6. 2x plus 6, since we're solving for x, we move the 6 to the right-hand side of the equal sign. And when we do that, the 6 becomes negative. So we have -6. And then to remain with x, we divide both sides by 2. So 2x divided by 2, we have x. Then -6 divided by 2, we have -3. So like that, divided by 2, divided by 2. We have x is equal to -3. So this is the point or the number at which this line crosses the x-axis. And so that point can be written as -3, 0. So this is our x-intercept. Then we do the same for the y. So using the same equation, since on the y-intercept x is 0, so we replace x with 0. So 2x multiplied by 0 plus 3y is equal to, plus 6 plus 6 is equal to 0. Then 2 times 0 is 0, remain with 3y plus 6. 3y plus 6, remove the 6, the right-hand side of the equal sign, and we have 3y is equal to -6. And then when we do the same, we divide by 3 both sides. We have y is equal to -2. And so the y-intercept is 0, -2. So we have 2 points here, -3, 0 and 0, -2. And since our goal is to find 2 points that we can plot and then join to come up with a graph, we have found those 2 points. So let me just erase so that we have space to do our graph. So we said our x-intercept was at -3, 0, and our y-intercept was at 0, -2. Let's have an x and y. So this is our y. And this is our x. And then we plot these 2 points. Say -3 on the x-axis is somewhere here, and then -2 on the y-axis is somewhere there. Then our line should go through these 2 points. And since my graphing is not accurate, I'm not sure if it's going to this time around. Let's see. Okay, so something like that. Yeah. So that is the graph. I know it's not accurate because I'm just imagining the positions, but if you have like a standard scale and you're using exact figures, you'll be able to have a situation where this line goes through the 2 points. So this is how the graph of ax plus bx plus c, which was in this case was 2x plus 3y plus 6 equal to 0, will look like. So again, the step is find the x-intercept, find the y-intercept. You have 2 points. Plot those 2 points, connect them with a line, and you have your graph. And then the last method I said I'll talk about is getting random values, like using random values to graph the line. So let me see if I can come up with an example. If I have an equation in standard form, let's say y is equal to 3x plus 1. So I can either use the method I spoke about earlier, like the first method I talked about, or I can just use a set of values like that. I can say x and y like that. And as I said, you only need 2 points. So you'd only need to compute 2 points like that. So I'm going to give x any random value. It could be 0, it could be 10, it could be 20, it could be negative 30, or any number that I feel would be easy for me to graph. So basically or in most cases, it's very easy to use a smaller number. So I say maybe 1 or even 0. And then I plug it in, get what y is when x is 0. Use another number, maybe 6, plug it in, solve the equation, get what y is. and then I have 2 points. Then I can plot those 2 points and come up with the graph of the line. So in this case, I'll use 0 and 1 just for easier mathematics. So when x is 0 and when x is 1. So when x is 0, y is equal to 3 times 0 plus 1. 3 times 0 is 0. 0 plus 1 is simply 1. So when x is 0, y is 1. When x is 1, we have y is equal to 3 times 1 plus 1. 3 times 1 is 3 plus 1, it's 4. So when x is 0, y is 4. When x is 1, sorry, y is 4. So we have 2 points. We have 0, 1, and we have 1, 4. Using these 2 points, let me see if I can squeeze my x and y somewhere here. Using the 2 points, I'll plot 0, 1. So 0, 1 is somewhere there. There's a point. And then 1, 4. Let me see. My 1 is here. So my 4 on the y should be somewhere there on top. So my other point will be here. And then since I have the 2 points, I can join them with a straight line. Like that. Again, I'm going to mention that the reason my line is not going through the points is because I'm just estimating. I'm just assuming that this point is what, this point is what. But if you have a standard scale, let's say for each division on the y-axis, you have like 2 centimeters, and each division on the x-axis 2 centimeters. If you plot the points, the line should be able to go through both points. But since I'm not doing like exact measurements, I'm just estimating. That is why my straight line does not go through the points exactly. But this is basically how you can graph a line. So using method 1, method 2, and method 3. Yeah, thank you for watching, and see you in the next video.